Hello guys, welcome back to O1 Tutor episode 2 of the series Number Theory. Very interesting title, when 7 equals to 1 and 8 equals to 2. Now you might think that, from the ordinary methods and from what we learned in high school, it's impossible to have two numbers that are not the same to be equal to each other. But this goes back to the space that you are dealing with, and in this video we are going to discuss a very important concept in number theory called congruences and residues. This concept goes back to the famous mathematician Gauss. Of course, you've heard of Gauss. Very, very important contribution he made. A very important contribution regarding to the number theory when he defined congruences and residues, which deal with the divisibility of numbers. Now recall, in the first episode we talked about the prime numbers, and these prime numbers, they are the numbers that are not divisible by any number smaller than themselves. The only divisors for prime numbers are 1 and themselves. And Gauss, when he introduced congruences and residues, he gave us very important tools to deal with the divisibility. And I believe personally that the answer of prime number distribution lies in this field of congruences and residues. Now, to explain congruences and residues, I want to explain it in a very simple manner. Suppose that we have in here a circle, some kind of operator, okay, and I'm gonna call it mod 3. So this is the space of mod 3. Like we have the space of integers of 0, 1, 2, 3, and 4. We have another space, let's call it mod 3. Okay, and any number entering this space, any number entering this machine or this operator, can have only 3 outputs. Okay, so the number that comes out of the mod, okay, are either 0, 1, or 2. Okay, which are all the integers less than 3 starting from 0. So this mod 3 is some kind of box that contains only 0, 1, and 2. Now let's see what congruences mean and what residues mean. Okay, so if you give this operator, which is mod 3, any number that is divisible by 3. So if you give it any number divisible by 3, such as 3, 6, 9, 12, any number divisible by 3, okay, it becomes 0 mod 3. So when I say that 6 is 0 mod 3, what I'm saying is 6 is divisible by 3. When I say that 9 is 0 mod 3, I'm telling you that 9 is divisible by 3. So any number divisible by 3, if you give it to the mod, it turns out to be equal to 0 mod 3. And I'm gonna outline, the examples in here. So for example, 3 is 0 mod 3. Okay, 6 is 0 mod 3. In fact, any number divisible by 3, meaning 3k, is equal to 0 mod 3 for any integer k. Okay, 0, 1, 2, 3, etc. Okay, so any number divisible by 3 becomes 0 mod 3, and we say that when I write 3 equals to 0 mod 3, the meaning of this in English words is 3 is congruent to 0 modulo 3. Okay, so in here, in English word 3 is congruent. When we say that it's congruent to 0 mod 3, this means that when 3 is divided by 3, it leaves a remainder of 0. So when I say 3 is 0 mod 3, this means that 3 is congruent to 0 mod 3. This means that 3 leaves a remainder of 0 when it is divided by 3. To make this simpler, I'm gonna give you the numbers that are not divisible by 3. They leave a remainder of 1 when they are divided by 3. So in any number, if you give the mod 3, any number that it leaves a remainder of 1, when divided by 3, remainder of 1 when divided by 3, we say it's equal to 1 mod 3. It's congruent to 1 mod 3. So any number that leaves a remainder of 1 when divided by 3 is equal to 1 mod 3. Very important. So in here, another example. So we say that, for example, 4, if you divide it by 3, it leaves a remainder of 1. So we say that 4 is congruent. Usually congruent is denoted as 3 dashes above each other, right? Not like the equal. So in here you have congruent. Okay, so 4 is congruent to 1 mod 3. This means that 4 leaves a remainder of 1 when divided by 3. Okay, and we say that 4 is congruent to 1 mod 3. Same thing for 7. 7 is 1 mod 3. Now how do I know that it leaves a remainder of 1? Because 4 can be written as 3 times 1 plus 1. Okay, so when you divide 4 by 3, it's 3 times 1 plus 1, it leaves a remainder of 1, and therefore 4 is congruent to 1 mod 3. And in fact, you can develop a formula in which 3k plus 4 for any integer k, 3k plus 4 is congruent to 1 mod 3. We still have the numbers that leave a remainder of 2 when they are divided by 3. So if you put in here any number that leaves remainder of 2 when divided by 3, we say that it is congruent to 2 mod 3. 2 mod 3. For example, 5 is congruent to 2 mod 3 because 5 leaves a remainder of 2 when divided by 3. And to explain this, 5 is equal to 3 times 1 plus 2. It leaves a remainder of 2 when divided by 3. Okay, same thing goes for 8. 8 is congruent to 2 mod 3. And in fact, any number having the formula of 3k plus 5, okay, is congruent to 2 modulo 3. Okay, so notice in here that mod 3, the only possible numbers in mod 3 that can exist are either 0, 1, or 2. Okay, because any number that you put it in modulo 3, it can either leave a remainder of 0 if it's divisible by 3, or a remainder of 1, or a remainder of 2. You cannot have anything remainder of 4 in modulo 3. In fact, any modulo n, so suppose that we're dealing with modulo 7 or modulo 11 or mod n, in general mod n, okay, where n is an integer, the only possible, values in mod n are 0, 1, 2, up to n minus 1. For example, if you're dealing with mod 7, okay, it's going to be 0 up to 6. The only possible numbers in mod 7 are 0 up to 6. Okay, so it's kind of interesting. It's kind of interesting to have this operation as a new way to deal with divisibility. Okay, and the mathematician that developed this notation is Gauss, the very famous mathematician Gauss, who developed congruences and residues. Residues are like the remainder. Okay, so when I say 7 is congruent to 1 mod 3, then the residue of 7 in mod 3 is 1. So it's kind of the remainder, right? Residues are remainders. Now, why are these spaces so important? Why are congruences so important? Remember that when I talked about primes are numbers that cannot be divisible by any number smaller than them. And if you put a prime number in any mode, there's no way you're gonna get a 0. Okay, because one consequence of what we talked about is that primes always leave a residue in any mode. So always leave a residue in any mode n. Okay, because if it left a 0, this means that this number is divisible by the mode, by the mode n, right? And therefore you cannot consider it as a prime. Let's take an example. For example, let's take the number 11. Okay, if you consider the primes that are less than 11, which are 2, 3, 5, 7, and you find the congruence, the residue of 11 when it entered any of these modes, you're gonna see that 11 leaves a residue of 1 in mode 2. 11 leaves a residue of 2 in mode 3. Okay, you're gonna see that 11 is gonna leave a residue of 1 in mode 5, and it's gonna leave a residue of 4 in mode 7. So notice none of these residues are 0, because if it were to be 0, 11 would be divisible by the number in here, right? Very important application, congruences. Before I finish up, I want to stress on the importance of congruences and in dealing with infinite numbers, in dealing with very, very large numbers. Now recall that to find a prime number, to find whether a number is prime or not, usually the ordinary methods were to take this number and start dividing it by all the prime numbers that are less than it, okay, to see whether it is prime or not. Now with the word of congruences, the process seems a bit easier, because let's take, for example, if I'm interested in finding 2 to the power k, okay, in mode 3. Very simple example. I'm trying to find what is 2 to the power k for k, is equal to 0, 1, 2, etc. in modulo 3. Look what's gonna happen. 2 to the power 0, we know that 2 to the power 0 is mode 3, and the only possible values in mode 3, we know that the only possible values in mode 3 are either 0, 1, or 2. So any number greater than 2 it can either be 0, 1, or 2. So 2 to the power 0 for k equals to 0, right? It's gonna be 1 mod 3. Now 2 to the power 1, it's gonna be 2 mod 3. 2 to the power 2 is 4, but 4 cannot exist in mode 3. So what you're gonna do is 4, you're gonna subtract it from it 3 to obtain 1. So 2 to the power 2 again is 1. mod 3 and not 4 mod 3, because you cannot have 4 in mod 3. Only possible values in mod 3 are 0, 1, and 2. 2 to the power 3, you can write it down as 2 to the power 2, right, times 2. So it's 2 to the power 2 times 2. 2 to the power 2 is 1 times 2. Okay, so it's 2 mod 3. So you start seeing a pattern. You start seeing a pattern, right? Notice the pattern in here, that 2 to the power any odd number, for example 1, 3, 5, etc. 2 to the power any odd number will give you 2 mod 3. However, 2 to the power any even number will give you 1 mod 3. Why is that important? Why is that important? Look why it's important. Because if I tell you, check if this number is divisible by 3 or not. 2 to the power 10, 113, 776, 334, 706, minus 1. If I give you this number and I tell you check whether it's divisible by 3 or not, what do? Of course you cannot calculate this number, because if you want to calculate it, if you want to do 2 to the power 10, whatever this is, times, okay, you are not going to finish, okay, and the number is going to be very, very, very large. However, by the means of congruences, we know that 2 to the power any even number is equal to 1. And since this number is even, because it ends with 6, right, we can say that in mod 3, this number in here is equal to 1. 1 minus 1 is 0. And since the resulting number, which is this, is equal to 0 mod 3, therefore we know that without any calculations that this number, which is 2 to the power whatever this is minus 1, is indeed divisible by 3. Because a number is divisible by another number when, so n is divisible by k when n is 0 mod k, and this is n, it's 0 mod 3, and therefore this number is divisible by 3. Look, one of the many nice and beautiful applications of congruences and residues, we are able to find whether this number is divisible by 3 without doing any calculations. So this number is divisible by 3 simply by, following this order and, discovering that 2 to the power any even number is equal to 1 mod 3. And since 2 to the power this number, is even, we can say that 2 to the power this even number is 1, but I subtract from it 1, another 1, so it's going to end up by being 0 mod 3. And since it's 0 mod 3, it is indeed divisible by 3. Very important concept, congruences and residues, developed by Gauss. I think the answer again to prime number distribution is hidden in the world of congruences and residues. You can dig deeper into this concept more to try to understand the distribution of primes. I hope you enjoyed this video, and I will see you soon in the next one. Thank you for watching, and have a good day.